accuracy. Okay, so we had a discussion on accuracy at the last, and we figure out that, for example, you have multiple models, this kind of models, and let's say they give us accuracy A1, A2, and A3, or you can also consider, let's forget accuracy, we can consider that, let's say you have models which gives us output P1, P2, and P3. Okay, and based on that we can calculate accuracy. Now we want to get the final output P. So what we were doing, that we were taking the average of it. This is the most basic method. But in practice, what will happen? That let's say you have these models M1 and M2 and M3. You may tend to assign them different weights. Let's say W1, W2, and W3. And based on that, you will be calculating output. For example, your output will be W1, P1. That is the output of this P1, P2, P3. These are the outputs. And these are the weights. This is your model. Plus W2, P2 plus W3, P3. Because all the models may not perform similarly. According to the performance, according to the accuracy, we may assign the different weights to different models. So how we can understand it with the real life example? Let's say you have a game of, there is a quiz going on. There is a quiz, and here is a person who is asking you a question. Here is a person. He asks you a question, and here you have a team, 4 people. Let's say 3 people for now. Let's say someone say there are 4 options. Okay, let's say there are option A, B, C, and D. This person say A, this person says, let's say the answer is B, and this person says the answer is C. All of them are speaking differently, and you are the team leader. Okay, you are the team leader standing out here. You have some vote, maybe say A, B, C, or whatever, but you want to listen to your teammates. So whose answer will you prefer? That's the question. That what is the answer of this question according to your team? So what will you do? Based on their previous performance, let's say this person answered 10 out of 11 questions correctly. This person answered 2 out of 5 questions correctly, and this person answered 3 out of 10 questions correctly. So obviously the question comes to you: whom will you listen? The most basic intuition says the person with higher accuracy will be given more weight. Okay, you will be listening to this person. Okay, the answer is A. So this is the same as weighted averaging. What we are trying to achieve is that we are trying to give the more weight to the output which has the more accuracy in the previous stage or on the previous input. So this is the thing which we are going to follow. So according to the weights of the different model, let's say you have one model decision tree, another model as logistic regression, another model as SVM. You will assign different weights. Let's say this model has weight W1, this model has weight W2, and this model have weight W3. Based on their inputs, you will do what? P1 W1 plus P2 W2 plus P3 W3, and this will be giving you the final output P. So I think this quiz example gave you a pretty well intuition of weighted averaging in practice actually, and let's see what next we can learn apart from this. Okay, so this was about weighted averaging, right? Next, we may see something called as features regarding to that. Uh, let me first give you a hint what we are studying. Since the time we have been learning different models and different things, but let's learn something which we use in practice, something called as bagging. So what is bagging? It's nothing but you have multiple models. You have multiple models working simultaneously to produce the final output. So how this will be achieved? What will it do? It will reduce variance. Okay, so now I am saying that we have multiple models M1, M2, M3, and M4, and we'll be giving them data, and they will be predicting a final output. The question comes here. This is called bagging. So how it is working actually? Let's see. You might have already learned something called as row sampling and feature sampling. If you don't, just let me tell you what these are basically. Let's say this is your data set. There are multiple features. Okay, let's say there is feature F1, F2, and up to Fn. There are multiple rows. So these are about basically your features, and these are your data entries. Data entries. Now, what will we do? Let's say in practical situation, if you have multiple models and you have data D, data, you name it as D, and it is very large. Now, if you give this data D to each and every model completely, what will it do? It will increase your time complexity. Let's say there are 10 million entries in each and every model. There can be hundreds of models, let's say, and 10 million records will be passed to hundreds of models. This will increase your time complexity. So in practice, what we do? In practice, we take some entries and some features, basically make permutation and combination in this, and feed two different models. Let's say we pass combination 1 to model 1, combination 2 to model 2, and so on. Okay, and this will reduce time complexity. Let me show you how. Let's say you have feature F1, F2, F3, F4, and up to Fn, and you have row 1, 2, 3, and up to n. So what you will do for model M1, let's say you choose F1 feature and F3 feature and pick some rows and give it to this model. Okay, now for model M2, you will pick F2 feature and let's say F5 feature and some rows according to this feature and give it to model M2. So this will now in turn reduce the time complexity, and it will evenly distribute your data based on this feature. Okay, so this is how we do row sampling and feature sampling. Next, we'll look at something called as random forest. Random forest. So what is random forest? In simple term, is the combination of decision trees. Okay, so first question is why random forest? Why we are learning random forest? Simple answer to this is that in decision tree there are some problems such as overfitting, that we'll discuss what is overfitting, and there is uncontrolled splitting. Okay, so these all things will lead us to use random forest. Now, also, since you have a decision tree, it looks like this. Okay. This is the decision tree you are talking about, and you have a large amount of data D, which is large. The single tree will have to process all this data, and it might be the case it will not perform that well. It will not perform that well. So what we do in random forest, We use multiple decision trees working parallelly. Let's say this is a decision tree D1, D2, and D3 and D4. And what we do, we provide different features. Let's say we have F1, F2, F3, F4 features. So what we do, we provide F1 feature and F2 feature here. We provide F3 feature and F4 here. We provide F2 feature and F1 feature here again. And let's say we provide F1 feature and F4 feature here. So what we'll do, each and every decision tree will learn some of the features, and finally it will be predicting a good output. And each tree will not be overloaded and hence overfitted. Okay. So what we are doing, we are basically splitting all the data into some features. Okay. So we can do feature selection with the help of random forest. Now, next we see what was overfitting. Okay, because we discussed that term. So let's have a brief look of overfitting. There are two terms associated with. One is bias and another is variance. So what is bias? Let's say you are doing training. What will you do? You will calculate the accuracy, but how closely your model is predicting the output on training, how well it is performing. At that time when you calculate the error, that is called bias. And at the time of testing, you will calculate the difference between predicted and actual output, that is called variance. So what is overfitting? Overfitting is basically what? Low bias and high variance. That means your model performs well on training but not that great on testing. In real life example, if you consider this, for example, you in a class you given students some problem. Let's say you given some math problem. Let's say you have to integrate x squared dx. Okay, and you given some other problem. Let's say you have to differentiate cos x sin 2x. You tell them to differentiate. Okay, your student in the class did it very well. Okay, so this was the time when you were training them. Now let's say in the test you given them what, x cube dx, and ask them to integrate. Now at that time they might not be able to answer it. They answered it not correctly. So this is what the case of variance. You are performing well on training, but in the test you failed. This is what happened with the decision tree because it tries to overfit. Overfitting, graphically, if you try to understand, let's say this is a linear regression, and you have output as this, and you want to draw a regression line, and you have some points also here, and this is basically your training data, and this is your test data. Let's say. So in case of overfitting, the line will go like this. It will try to match all the training data. So this is what happening when at the time of training. If you calculate the accuracy will be high, but at the time of testing, accuracy will be low. So this is not a generalized model. If you want good accuracy, your line should go like something like this between here, so that at the time of training it also performs well, at the time of test it also performs well. So this is what overfitting is. Next thing we are looking at that something called boosting. How we can understand boosting? We are doing something sequentially. So how sequentially we are doing? as I have already told you, we try to perform something with the help of previous thing. Let's consider an example. You want to prepare cake, make a cake, make a cake. So what we'll do? First step, you will whip the cream. You will uh, uh, make the base, place them together, and finally you will apply toppings, and furnishes. So these are all the steps. So these are independent, and at each step we are trying to achieve some of the other tasks. Okay, this is basically a basic example of boosting. Okay, and finally you will be getting the output. This is the simplest explanation of boosting I could tell you. Okay, now uh, if we talk this algorithmically, algorithmatically, basically about boosting, what we'll do in first step one, we will train some classifier M1 and we'll check the accuracy. In step 2, we'll take this accuracy and based on this we'll train model M2, and in the third step we'll aggregate. Okay, I'll consider an example. Let's say you are making a pot, and you are not very great at making pots. So in the first step, you will try to make some bad pot, because this is a pot. Now the teacher will come and try to reshape it and give it some better shape. Okay. Now since you have a better shape than before, in the next step you will see what differences it had, and finally you will be making a good pot next time. It now looks best. So this is the thing. You are comparing the previous inputs and making the amendment to the next steps you are going to take. This is the simplest explanation of boosting. Next, we'll be looking at two things, something called as boost and gradient boost, and third, XG boost. These things will be looking next. Okay, so these are basic examples of boosting. So, thank you till then.